Assalamualaikum. Welcome to my car. My group want to present about turbine. They are name of team member of my group. First Muhammad Irfan bin Zulkifli. Second Siti Maimunah binti Zamri. Third Muhammad Amirul Naim bin Muhammad Jeffrey. Jerikel anak Wellington. Nurul Aini binti Mahadi. Anas Farhad bin Muhammad Syukri. That's all.
What is a turbine? Turbine is a rotary mechanical device that extracts energy from a fluid flow and converts it into a useful work. The work produced by a turbine can be used for generating electrical power when it combined with a generator. Besides, the turbines can produce work from the fluid that passes through the blades and the shaft rotates.
Assalamualaikum warahmatullahi wabarakatuh. Turbines are used in many different areas and each type of turbine has a slightly different construction to perform its job properly. Turbines are used in some systems like wind power, hydropower and also in heat engine. Wind energy play an important role in majority of the applications such as flour mill, lift water and to lift the load. Hydroelectricity is some of the application of hydropower to generate electricity. It is the primary use of hydropower today. Heat engine commonly used in airplane. We can see turbines are extremely important because of the fact that nearly all electricity is generated by them. The working principle of turbine is very simple. First, when the fluid strikes the blade of the turbine, the plates are displaced, which produce rotational energy. Second, when the turbine shaft is directly coupled to an electric generator, mechanical energy is converted into electrical energy. This electrical power is known as hydroelectric power. There are several types of turbine, which is water turbine, steam turbine, gas turbine, and wind turbine. Although the same principle apply to all turbines, their specific design differs sufficiently to merit separate description. Here, in this video, we will focus on the turbine in heat engine system. In the next slide, my friend will discuss how the turbine operates on heat engine system.
Hello, okay, now I will explain how the turbine operates in heat engine. First of all, a turbine is a device that harnesses the kinetic energy of some fluid, such as water, steam, air or combustion gases, and turns into the rotational motion of the device itself. Turbines are commonly used in heat engines because of their high efficiency and high outputs. Additionally, turbines require fairly little maintenance. Gas turbines are used frequently in heat engines, as they are one of the most flexible types of turbines. One specific application of these gas turbines is in jet engines. In these gas turbines, compressed air is heated and mixed with some fuel. When this mixture ignites, it undergoes rapid expansion. The expanding air is pushed into the turbine, causing it to spin. Since they use compressed air, high altitudes do not affect the efficiency of the turbines, making them ideal for use in airplanes. A diagram of gas turbine is shown in this slide. As well as being used in airplanes, these turbines are used to generate electricity in natural gas fuel power plants. The combustion gases in this case arise from the combustion of natural gas.
So the next thing is the first law of thermodynamics simplified. The first law of thermodynamics says the sum of the energy put into the wind turbine plus the remaining energy in the air after it passes through the turbine must exactly equal to the energy in the wind before it enters the turbine. And for the second law of thermodynamics in turbine, the second law of thermodynamics states that heat flows spontaneously only from hotter to colder bodies. This implies that a steam engine can do work only with a drop in temperature. The steam that enters a steam turbine is hotter than the steam that exits it, which means the turbine. The loss in heat energy by the steam is converted by the turbine to the electricity. It is really a two-step process, first from heat to mechanical energy, and then it goes to electrical energy.
Thermodynamic calculation relate with turbine. Steam flows steadily through an adiabatic turbine. The inlet condition of the steam are 4 MPa, 500 degree and 1880 ms minus 1, and the exist condition are 30 kPa, 92% quality and 50 ms minus 1. The mass flow rate of the steam is 12 kg minus 12 kg s minus 1. Determine A. The change kinetic energy, B. The power output, and C. The turbine inlet area. From the question, we can know P1, T1, velocity for 1, and P2, X2, velocity for 2. Steady flow adiabatic means that mass flow rate for outlet and inlet is same, and potential energy equal to 0. Heat Q naught also equal to 0. From first law, we can use equation Q naught minus W naught equal to M naught multiplied by H2 minus H1 plus V2 squared minus V1 squared divided by 2 and plus G multiply Z2 minus Z1. In this question, Q naught equal to 0 and Z also equal to 0. So, we can get the equation minus W naught equal to M naught multiply by H2 minus H1 plus V2 minus V2 squared minus V1 squared divided by 2. Formula for kinetic energy is V2 squared minus V1 squared divided by 2. So we can use the equation to get the solution. H2, H1 and V1 specific volume we can get from the table. Equation for mass flow rate equal to area multiply by velocity divided by specific volume. For the inlet, P1 equal to 4 MPa, so equal to 4000 kPa. From the P1 we can get T saturated. So T saturated equal to 250.33 degree. We can get from table A5. T1 equal to 500 degree. So from the T1 we can get V1 and H1. So V1 equal to 0.08944 and H1 equal to 3446.0. We can get from table A6. T1 bigger than T saturated, so this phase for the inlet is superheated vapor. For the outlet, P2 equal to 30 kPa. So from the P2 we can get HF and HFG. So HF equal to 289.27 and HFG equal to 2335.3. We can get from table A5 too. H2 we can get from the equation that H2 equal to HF plus X HFG. So we get H2 equal to 2437.75. So we can also find the kinetic energy with the equation V2 squared minus V1 squared divided by 2. So we get kinetic energy is minus 1.95 kg per kg. For the power output, we can use word equation of work. So minus W naught equal to M naught multiplied by H2 minus H1 plus kinetic energy. So W naught equal to minus 12 kg per S multiplied by 2437.75 minus 3446.0 plus minus 1.95. So W naught equal to 121222 kilowatt equal to 12.1 megawatt. For the area in inlet, we can use the equation for mass flow rate. Mass flow rate equal to area multiplied by velocity divided by specific volume. So area for inlet is 0.013.
Good evening. So today I'm gonna show you the TV diagram and the PV diagram. So what is the function of TV diagram and PV diagram? So just now my friend just told about the question whereby we are given P1 equal to 4 megapascal with temperature of 500 degrees Celsius, P2, and we are given X, and whereby X is equal to 0.92. So what is the function of the diagram? Both diagram indicates what is the phase during the region. So the first phase is, based on the diagram, we can get superheated vapor region. Why? When for the TV diagram, we get P1 is equal to 4, while P2 is 30 kilopascal, and we get to know that P2 is equal to constant, which is larger than P1. So from that we get to understand that P1 or region 1 is at superheated vapor region. So we can refer to table A6 and in conclude that P2, how we get P2 is saturated liquid vapor region when X is equal to 0.92. This is because when X equal to 1 is near to the region of superheated vapor region, while when X equal to 0 is near to the compressed liquid region. So X is equal to 0.62, which is greater than X equal to 0. So meaning that the region where the second phase is at the inside of the graph. So now for the PV diagram, whereby they also the same as TV diagram, but the how to understand PV diagram is whereby T2 is higher than T1. How we know that T2 is higher than T1? Although we don't know that T2 is higher than T1, we can understand that the region for 2 is at region for phase 2 is inside the saturated liquid vapor region. But how do we know it's superheated vapor region for 1? There are some of what we call that term inside the PV diagram, whereby you can see at the pressure or other than that. So in conclusion, the both diagrams help us to understand the state possessed by each region. So when we understand where is the region of each phase, so we know which table we use for each to solve the problem. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi everybody. What I have learned from producing this video it was a fantastic way to contribute to your English language learning experience. This presentation enabled me to practice all language areas such as vocabulary, phonology and grammar, and also skill like speaking, reading, writing and listening. But most of all, this presentation built my confidence in public speaking. Thank you. Right.
Assalamualaikum warahmatullahi wabarakatuh, and hi everything. So basically what I've learned from this video presenting, I learned a lot how to improve my self-confidence, and apart from that I also learned a lot about how turbine works in thermodynamics.
In my opinion, it has pros and cons. Group members will have enough of time to do some research and try to finish their assignment before the due date. Unfortunately, for those who didn't have a good internet access, will face some problem to finish their assignment. But we are lucky because our lecturers can tolerate with us and give us enough time to finish our assignment. That's all.
So what I learned during this I can understand the importance of diagram in explaining the properties of a sustain. Second, we can enhance our cooperation between friends and also give ourselves a self-confident boost to be more forward and to present something. That's all. Thank you.
Okay, what I get from this slide is how to solve the problem that relate with turbine. I know if the question is about the steady fluid adiabatic, so mass flow rate in outlet and inlet are same, potential energy equal to 0, and Q naught heat also equal to 0. I also know that equation in first law thermodynamics. For example, equation for kinetic energy. Kinetic energy equal to velocity for outlet square minus velocity for inlet square divided by 2. I know how to use table to get H1, H2 and specific volume. That's all.
By producing this video, I learned about the system of a turbine. Besides, I also learned how to understand the formula related to the thermodynamics law and the applications applied to it. Lastly, I hope that this video can make it easier for all of us to understand the thermodynamics law more and more. Thank you.